All right, so in this example, we're going to look at these operations and determine whether they have the qualities of closure, whether they're commutative or associative. All right, so we've got our operation x star y is x plus y divided by 2, and that's part of rationals. Well, if I take any two rationals and add them and then half them, so we could rewrite our x star y as half x plus y. So the sum of two rationals is rational. Half of that is also going to be rational. So that's always going to be an element of rationals. Therefore, it's closed. All right. Commutative? Well, addition is commutative. So half of x plus y is the same as half of y plus x. So yes, it is commutative. I'm just going to abbreviate that as commutative. All right, now we want to think about associative. So for this, we're going to add in a z. So we want to know if x star y star z is the same as x star y star z. All right, so let's look at the left-hand side and the right-hand side. So left-hand side, x star y star z is going to be x plus y plus z over 2, whole quantity over 2. So take the first element, we're adding it to the second element. Second element is going to be our whole operation. And the question is this equal to x plus y over 2 plus z over 2? If we simplify these out, we're going to discover that they are not equal. I'm going to leave that simplification up to you if you want to go further to prove it, but you should see from this pretty much already that they're not going to be equal. So let's switch this out. Those are not equal, therefore it's not associative. All right, let's look at example B. So in B, we have integers, and we've got 3x minus 2y. Well, taking integers and subtracting them, we're always going to get another integer. So this is closed. So 3x minus 2y is an element of integers for x and y being elements of integers. Therefore, it is closed. Okay. Subtraction is not commutative. So straight away, so in this case, star is not going to be commutative. All right, let's look at x star y star z. That's going to be, let's start with the y star z. That's going to make 3y minus 2z. Now this is going to be my new y element, so I'm going to have 3x minus 2 times that quantity. X star y star z. So all of this is going to be my x value. So 3 times 3x minus 2y minus 2z. Straight away, this is going to give me a positive 4z, which I'm not going to have down here. Therefore, these two things, the left-hand side doesn't equal the right-hand side, therefore it is not associative. All right, example C. Now we've got reals excluding 0, xy over x plus y. So if we think about whether this is closed or not, xy over x plus y, well, if x is equal to 1 and y is equal to negative 1, I'm going to end up with a value that is not an element of reals. So this is not always element of reals, so it's not closed. And for example, x is 1 and y is negative 1. All right. We've got multiplication and addition. Both of those are commutative, so this is commutative. All right. Is it associative? I'm going to go with probably not, just by looking at it. X star y star z star z. That's going to give me, thinking of my y star z, so I'm going to have yz over y plus z. So x yz over y plus z over x plus yz over y plus z. All right, looking at the right-hand side, we're going to have x star y, quantity star z. So we're going to end up with xy over x plus y times z over xy, x plus y plus z. All right, let's look at this left-hand side, simplifying it out. I'm going to multiply top and bottom by y plus z. So I'm going to get x, y, z on the top. On the bottom, I'm going to get x times y plus z plus yz. So that's going to give me xyz over xy plus xz plus yz. All right, looking at this side, multiply top and bottom by x plus y. I'm going to get xyz again over xy plus z times x plus y. That's going to give me xyz over xy plus xz plus yz. And notice, left-hand side equals right-hand side. Therefore, yes, it is associative. First associative one we've seen. All right, D is our last one here. And in D, we can see that we've got our set of numbers here is 2 to the n. So 1/2, 1, 2, 4, 8, etc. And x star y is x plus y. And n is an element of rational numbers. Well, if we think about rational numbers here, one example is that we could say that x is equal to, let's say, 2 to the 1/3, and y is equal to, let's say, 2 to the 1st. So then x star y is going to be 2 to the 3rd plus 2. Well, that's cube root of 2 plus 2. There's no way to simplify this down so that I can write it as 2 to the power n. I can't combine these in any way. So therefore, this is not closed. Okay. Thinking about commutative, addition is commutative, so yes, it's commutative. And then associative, we're going to want to know if x star yz is the same as x y star z. Again, we've got addition. Addition is associative. So yes, this is also associative. All right, so that's looking at closure, commutativity, and associativity.